coordinator of this program, and other esteemed participants. Now we have assembled here to make some discussion on the issue measures of relationship. First of all, I must mention that this session is meant for beginners, not for the experts in research methodology. So we have to discuss measures of relationship. So before starting discussion on this issue, let us recapitulate two very important terms which are associated with research methodology. One is variable and the other is attribute. We all know that any quantitative character, any character which is stated or which is measured numerically is called variable. On the other hand, any character which cannot be measured numerically is called attribute. The character of statistical information collected from a group of individuals or objects is of two types. One is quantitative and the other is qualitative. And so the qualitative character is called variable. Quantitative character is called variable and qualitative character is called attribute. So variable can be measured numerically. For example, age, weight, height. Age may be 30 years, 40 years, 50 years. Similarly, weight may be 20 kg, 30 kg, 40 kg, like that. But attribute is qualitative in nature. That means qualitative character is called attribute. Attribute cannot be stated numerically. A variable takes different values and these values can be measured numerically in suitable terms. Whereas an attribute cannot be measured numerically, but it can be classified under different heads or categories. For example, the number of, suppose all the participants can be divided into two categories on the basis of one attribute skill, that is skilled participants and unskilled participant. Similarly, all participants can also be divided into three categories: skilled participants, semi-skilled participants, and unskilled participants. So we can say that again, attribute cannot be measured numerically, but it can be classified under different heads. Now, first of all, we have to consider variable and measures of relationship. There are several measures which can be used for assessing the extent of relationship between two or more variables. Now,
excuse me, sir.
Yes.
Your slide is not changing.
Hello, changing?
Yes, sir. Your slide is not changing.
Now, is it changing?
No, sir.
Sir, I think the slideshow is not on.
It is on. One thing. Oh, stop sharing. Okay. Some problem is there. Please wait. স্লাইডটা চেঞ্জ হচ্ছিল না,
এটা তো অফ করে দিই। এরকম ভাবেই করো না, ছোট অবস্থাতেই করো না, যদি
হ্যাঁ।
প্রবলেম হয়।
আচ্ছা, ওকে ওকে, এবার দাঁড়া, এবার এটা কি অন করব কি করে? স্টপ শেয়ারিং হয়ে যাচ্ছে।
স্টপ শেয়ারিং করছো কেন তুমি? দাও না, দাও না। বাস,
কি করব?
এবার তো হয়ে গেছে, তো এবার জাস্ট এই করো না।
কি করব? শেয়ার করব?
শেয়ার করা আছে অলরেডি, এবার এখানটা দাও। হ্যাঁ হ্যাঁ, এবার just click করো।
ওকে ওকে। হ্যালো, ইজ ইট ভিজিবল?
Yes, sir, it is visible. Now it is also changing.
ভিজিবল?
Yes, sir,
Next.
visible.
নেক্সট?
Yes, sir, next is
It's okay now.
Okay, now okay. Okay, thank you. So let us consider some important measures. First of all, Pearson simple correlation. We all know that Pearson simple correlation measures the degree of relationship between two variables, ignoring the existence of any other variable or variables which might have relationship with these two variables. That means if we have two variables, and if we want to determine the degree of relationship between them, then we have to use Pearson simple correlation. And in Pearson simple correlation, it is assumed that there is no other variable which can influence these two variables. That means if we suppose we have two variables, age and weight, age of students and weight of students. So we have two variables, and if we want to calculate the degree of relationship between these two, age and weight, we have to follow Pearson simple correlation coefficient formula. And here it is assumed that there is no other variable which can influence these age and weight. But in practically we know that age and weight may be influenced by various factors. But in case of Pearson simple correlation, it is assumed that this age and weight are not influenced by any other variable. So this is also one of the limitations of Pearson simple correlation. So now this is the formula. Generally, Pearson simple correlation coefficient is denoted by Rxy, where x and y are the two variables, and it is denoted by small rxy, covariance xy divided by standard deviation of x into standard deviation of y. Actually, or practically, we calculate any types of correlation or any statistical calculations with the help of certain statistical package like SPSS. So it is not mandatory to remember always this formula, but we have to know the interpretation. So Pearson simple correlation coefficient varies between +1 and -1. That means the maximum value of Pearson simple correlation coefficient is +1 and the minimum value is -1. There are several types of simple correlation, Pearson simple correlation. The first one is positive correlation. Suppose we have two variables x and y, and if the value of x tends to increase as the value of y increases, or if the value of x tends to decrease as the value of y decreases, then the correlation is called positive correlation. That means if the values of the two variables x and y move in the same direction, then the correlation is called positive correlation. Generally, we find positive correlation in case of correlation between age and weight, between height and weight, between cost and profit. That means if age increases, weight increases. If height decreases, weight decreases. If cost increases, price increases. So there is a positive relationship between age and weight, or height and weight, or cost and price. Next one is negative correlation. If the values of x if the values of x increase with the decrease in the value of y, that means if value of x tends to increase as the value of y decreases, or if the value of x tends to decrease as the value of y increases, that means if the values of the two variables move in the opposite direction, then the correlation is called negative correlation. Generally, we find the correlation between price and demand. It is a negative correlation. If price increases, demand goes down. Similarly, negative correlation we find in case of the relationship between rainfall and temperature. If rainfall increases, temperature goes down. So there is a negative relationship between price and demand, or relationship between rainfall and temperature. Next one is zero correlation. If the value of x is not influenced by value of y, or if the value of y is not influenced by value of x, that means if the values of x and y are independent, then the correlation is called zero correlation. Generally, if we consider two variables, for example, number of cricketers in a village and number of and amount of fertilizer consumed in that village, generally there is no relationship between these two. That means number of cricketers does not depend on the amount of fertilizer used, or amount of fertilizer used is not influenced by the number of cricketers. So this is a case of zero correlation. And next one is perfect positive correlation. If the values of the two variables x and y move in the same direction, and if there is a linear relationship between them, then the correlation is called perfect positive correlation. In other words, if we plot all the values of the variables x and y on a graph paper, and if we find a upward rising straight line, then the correlation is called perfect positive correlation. And in case of perfect positive correlation, the value of rxy is equal to +1. Next one is perfect negative correlation. If the values of the two variables move in the opposite direction and there is a linear relationship between them, then the correlation is called perfect negative correlation. In other words, if we plot the values of x and y on the graph paper, and if we find a downward sloping straight line, then the correlation is called perfect negative correlation. And in case of perfect negative correlation, the value of rxy is equal to -1. Next one is spurious correlation or nonsense correlation. This is not given in this slide. Spurious or nonsense correlation. That means if there is a mathematical relationship between these two, mathematical correlation or mathematical relationship between these two variables, but there is no cause and effect relationship between them, then the correlation is called spurious correlation or nonsense correlation. That means mathematically a correlation exists between two variables, but there is no cause and effect relationship between them, then the correlation is called spurious correlation or nonsense correlation. That means if we find mathematically a correlation between size of shoes and intelligence score, then this correlation is called spurious correlation or nonsense correlation, because we all know that size of shoe does not influence intelligence score, or intelligence score does not influence size of shoes. They are independent. So here also, generally where zero correlation is expected, but if we find any correlation mathematically, then the correlation is called spurious correlation or nonsense correlation. Now, we all know that I have already mentioned the maximum value of simple correlation coefficient is +1 and minimum value is -1. It varies between +1 and -1. But at the time of interpretation, its significance is more important. That means the value, whether the value of correlation is statistically significant or not, this is more important, because this can be compared with this example. Suppose if a student of class 1 gets 90 in mathematics, this may not be considered as a significant marks. Why? Because we all know that many students of class 1 get 97, 98, even 100. That means 90 is not at all significant in case of a class 1, in case of a student of class 1. Whereas a student of master degree level, if a student of master degree level gets 80 in mathematics, then we can say that this is a very significant marks. The performance of that student is very good. So here, because it is not an easy task of obtaining 80% marks in mathematics at the master degree level. That's why we can say that this marks is very significant. This marks is highly significant. Whereas 90, which the student of class 1 got, is not at all significant. 90 is not at all significant. Similarly, in case of correlation, a high value may not be significant, whereas a low value may be significant. Generally, it depends on the size of sample. Here, in order to examine whether the computed value of correlation is statistically significant or not, t-test is used, where t equal to rxy into root over n minus 2 divided by 1 minus r square, where rxy is the simple correlation coefficient, n is the number of pairs of observations. Here, degree of freedom is n minus 2. That means if we consider 20, number of pairs of observations is 20, then 20 degree of freedom will be 20 minus 2. That means 18. So if the computed value of t is greater than or equal to the table value, that means the standard value of t, then we can say that the correlation is statistically significant. On the other hand, if the computed value of t is lower than the table value, that means the standard value of t, then we can say that the correlation is not at all significant. The correlation is statistically insignificant. So first of all, we have to compute correlation, then we have to compute t value, then we have to determine the degree of freedom, and then we have to identify the table value of t, and then we have to compare the computed value of t with the table value of t, and interpretation is made by applying this principle. Principle is that if the computed value of t is greater than or equal to the table value of t, then the correlation is statistically significant. Whereas if the computed value of t is lower than the table value of t, then the correlation is statistically insignificant. Next, partial correlation. Suppose we have three variables, x1, x2 and x3. And if we want to calculate the degree of relationship between x1 and x2 after eliminating the influence of x3 on x1 and x2, then the correlation is called, then we have to use partial correlation. That means if we have three variables, suppose we have three variables x1, x2 and x3, the degree of relationship between x1 and x2 after eliminating the influence of x3 on x1 and x2, then the correlation is called partial correlation between x1 and x2. For example, if we have three variables, yield of crops, amount of fertilizer used and amount of rainfall, we all know that yield of crops generally depend on amount of fertilizer used and amount of rainfall. That means yield of crops is influenced by amount of fertilizer used and amount of rainfall. But if we want to calculate the degree of relationship between yield of crops and the amount of fertilizer used after eliminating the influence of rainfall on amount of fertilizer used and amount of fertilizer used and yield of crops, then we have to calculate partial correlation coefficient between yield of crops and amount of fertilizer used. So again, if we generalize it, the degree of relationship between x1 and x2 after eliminating the influence of x3 on x1 and x2 is called partial correlation between x1 and x2. Partial correlation generally denoted by R12.3. Here, this is the partial correlation between x1 and x2. That means it indicates the degree of relationship between x1 and x2 after eliminating the influence of x3 on x1 and x2. And here, this is the formula R12 minus R13 into R23 divided by root over 1 minus R13 square into 1 minus R23 square, where R12 is the simple correlation between x1 and x2, R13 is the simple correlation between x1 and x3, R23 is the simple correlation between x2 and x3. Partial correlation also varies between +1 and -1. That means the same interpretation in case of simple correlation. That means the maximum value of partial correlation is +1 and the minimum value of partial correlation is -1. It varies between +1, -1. That means it may be positive, it may be negative, it may be 0, it may be perfect positive, it may be perfect negative. Okay. Partial, in order to examine whether the partial correlation coefficient is statistically significant or not, t-test is used. Here also t-test is used, where t equal to rp into root over 1 minus k divided by 1 minus rp square, where rp is the partial correlation coefficient, n is the number of pairs of observations, k is the number of variables involved. That means if we have three variables, yield of crops, amount of fertilizer used and amount of rainfall, then k equal to 3 and n number of years. Suppose if we consider 10 years data, if we consider 20 years data, then n equal to 20. If we consider 10 years data, then n equal to 10 and rp is the partial computed value of partial correlation coefficient. Here degree of freedom equal to n minus k. That means here suppose we have used 20 years data. That means n equal to 20 and we have three variables. Yield of crops, amount of fertilizer used and amount of rainfall. That means k equal to 3. So 20 minus 3, 17 is the degree of freedom. So again, the same principle we have to follow. If the computed value of t is either greater than or equal to the table value of t, then we can say that the partial correlation coefficient is statistically significant. On the other hand, if the computed value of t is lower than the table value of t, then the correlation coefficient, partial correlation coefficient, is statistically insignificant. Next one is multiple correlation. So, if we have 3 or more variables, and if we want to calculate the degree of relationship between the dependent variable and the joint influence of the independent variables, then we have to calculate multiple correlation. For example, suppose we have 3 variables x1, x2 and x3, and if we want to calculate the degree of relationship between x1 and the joint influence of x2 and x3 on x1, then we have to calculate multiple correlation of x1 on x2 and x3. So the degree of relationship between x1 and the joint influence of x2 and x3 on x1 is called multiple correlation of x1 on x2 and x3. Actually, x1 here, x1 is the dependent variable and x2 and x3 are the independent variable. Now we can cite one example, the similar example, that we have 3 variables: yield of crops, amount of fertilizer used and amount of rainfall. We all know that yield of crops is influenced by amount of fertilizer used and amount of rainfall. So yield of crops is the dependent variable and amount of fertilizer used and amount of rainfall is the independent variable. So if we want to calculate the degree of relationship between yield of crops and the joint influence of amount of fertilizer used and amount of rainfall on yield of crops, then we have to calculate multiple correlation coefficient of yield of crops on amount of fertilizer used and amount of rainfall. And this is the formula. Generally, multiple correlation coefficient is denoted by capital R 1.23. 1, that means x1 is the dependent variable, x2 and x3 are the independent variable. This is equal to r12 square plus r13 square minus 2 into r12 into r13 into r23 divided by 1 minus r23 square. Here also the same thing. R12 is the simple correlation coefficient between x1 and x2. R13 is the simple correlation coefficient between x1 and x3. And R23 is the simple correlation coefficient between x2 and x3. Multiple correlation varies between +1 and 0. That means multiple correlation coefficient cannot be negative. Whereas simple correlation coefficient and partial correlation coefficient vary between +1 and -1. But multiple correlation coefficient varies between +1 and -1. That means the maximum value is +1 and 0. Multiple correlation coefficient varies between +1 and 0. That means the maximum value of multiple correlation coefficient is +1 and minimum value of multiple correlation coefficient is 0. That means it cannot be negative. Suppose multiple correlation coefficient is 0.6, then we can say that it indicates, suppose the multiple correlation coefficient of yield of crops on amount of fertilizer used and amount of rainfall is 0.6. It indicates that there is a moderate degree of relationship. There is a moderate degree of relationship between the yield of crops and the joint influence of amount of fertilizer used and amount of rainfall. Here we have not mentioned whether it is positive or negative, because all multiple correlation coefficient values are positive. These multiple correlation coefficient cannot be negative. Okay, so we have to determine only the degree, only the extent of relationship. Okay. Here also we have to examine whether the multiple correlation coefficient is statistically significant or not. In order to examine whether the multiple correlation coefficient is statistically significant or not, F test is used. Here F equal to r square divided by 1 minus r square into n minus k minus 1 divided by k, where r is the multiple correlation coefficient, n is the number of objects under considerations, k is the number of independent variables. Here k is the number of independent variables. So in our example, number of variables 2. One is yield of crops and the other is sorry, one is amount of fertilizer used and amount of rainfall. These are independent variables. So k equal to 2 here. And here degree of freedom k n minus k minus 1. That means if we consider 20 years data, then here n equal to 20. So, and k equal to 2. So 2 comma then 20 minus 2 minus 1, that means 17. So 217 is the degree of freedom. So the same rule here we have to follow. If the computed value of f is greater than or equal to the table value of greater than or equal to the table value of f, then we can say that the multiple correlation coefficient is statistically significant. Whereas if the computed value of f is lower than the table value of table value of f, then we can say that the multiple correlation coefficient is statistically insignificant. Next one is Spearman rank correlation. We all know that if we have two variables, generally, and if we want to determine the degree of relationship between them, we have to generally Pearson's simple correlation coefficient. But if the data are qualitative in nature, then it is better to apply Spearman rank correlation coefficient instead of Pearson's simple correlation coefficient. So if we have two variables and if we want to determine the degree of relationship between them, and if the data are qualitative in nature, then we have to use Spearman rank correlation coefficient in place of Pearson's simple correlation coefficient. For example, we have considered 50 students and we have considered marks in mathematics and marks in statistics, and we want to determine the degree of relationship between the scores of the students in mathematics and statistics. That means, is there any relationship between marks in mathematics and marks in statistics? We have to follow Spearman rank correlation coefficient, because marks in mathematics and marks in statistics both reflect the quality of the students. Similarly, skill score, intelligence score, these are also indicate the quality of the students. So ability to play cricket, so ability to play teach physics. So these are, if data are qualitative in nature, and if we have two variables and if we want to determine the degree of relationship between them, then it is better to apply Spearman rank correlation coefficient instead of Pearson's simple correlation coefficient. And Pearson actually Spearman rank correlation coefficient represents the correlation coefficient between the ranks of the values of the two variables. So we can say that Spearman rank correlation coefficient is entirely based on Pearson's simple correlation coefficient. Actually, it is nothing but the simple correlation coefficient, Pearson's simple correlation coefficient between the ranks of the values of the two variables. Okay, Spearman rank correlation coefficient these are the formulae. Actually, there are two conditions. One is when tie arises and when tie does not arise. That means if two students or two companies or two objects rank the same, that means occupied the same rank, captured the same rank, then we can say that this is that means the tie arise. That means if two students got 90 each. So obviously it is a case of tie. So if tie arises, the second formula we have to apply, and if there is no tie in ranking, then the first formula we have to apply. R equal to 1 minus, here also Spearman rank correlation coefficient is generally denoted by capital R, and this is equal to 1 minus 6 into sigma di square divided by n cube minus n, where n is the number of individuals ranked, and di is the difference of ranks of the ith individual in the two characters. That means di equal to the difference between the ranks of the values of the variable. But if tie arises, the second formula we have to use, R equal to 1 minus sigma di square plus sigma t cube minus divided by 12 divided by n cube minus n, where just only thing, that is t, small t. Here t is the number of individuals involved in a tie. That means if 3 students got 90 marks, that means here one tie arises, and this tie here 3 students are involved in this tie. Here t equal to 3. Similarly, in another case, 2 students got 75. That means here also tie arises, and in this tie 2 students are involved. So here t equal to 2. So this is the second formula we have to apply in case of tie. But if there is no tie, then we have to apply the first formula. As the Spearman rank correlation coefficient is entirely based on simple correlation coefficient, Spearman rank correlation coefficient also varies between +1 and -1. That means the interpretation is similar as we have done in case of Pearson simple correlation. So the maximum value of Spearman rank correlation coefficient is +1 and minimum value is -1. Here also, in order to examine whether the computed value of Spearman rank correlation coefficient is statistically significant or not, t-test is used. Similarly, t-test we have to use. Here t equal to just same formula. In case of Pearson correlation coefficient, we find Rxy into root over n minus 2 divided by 1 minus Rxy square. Here, in place of Rxy, we put capital R. That means Spearman rank correlation coefficient. Capital R into root over n minus 2 divided by 1 minus R square, where n is the number of pairs of observations. Here also degree of freedom is same, n minus 2. So here the same principle we have to follow. If the computed value of t is greater than or equal to the table value of t, then the Spearman rank correlation coefficient is statistically significant. On the other hand, if the computed value of t is lower than the table value of t, then we can say that the Spearman rank correlation coefficient is statistically insignificant. So next one is Kendall's coefficients of concordance. Kendall's coefficients of concordance. So if we have 3 or more variables, and if we want to determine the degree of relationship among them, then we have to use Kendall's coefficients of concordance. If we have, and if the data are, obviously the data are qualitative in nature. So if we have 2 variables, and if we want to determine the degree of relationship between them, and if the data are qualitative in nature, we use Spearman rank correlation coefficient. But if we have 3 or more variables, and if we want to determine the degree of relationship among them, and if the data are qualitative in nature, then we have to use Kendall's coefficients of concordance. So Kendall's coefficients of concordance is a measure used for determining the degree of relationship or the degree of uniformity among 3 or more variables if the data, in case of qualitative data. Actually, this is used in case of qualitative data. That means marks in mathematics, marks in statistics, marks in business management. So if we want to determine whether there is any relationship among them, we have to use Kendall's coefficients of concordance. Kendall's coefficients of concordance is generally denoted by W. Here, W equal to capital W, W equal to small s divided by 1. Actually, here also, the same case, we have two formulae. One is applicable in case of no tie, in case of absence of tie. That means in case where there is no tie. But if the second formula we can apply when there is at least one tie. That means if tie arises, the second formula can be applied, and if tie does not arise, the first formula can be applied. So W equal to small s divided by 1 by 12 into k square into n cube minus n, where s equal to sigma Ri minus R bar whole square, where R is the sum of ranks assigned to each individual. Suppose I got highest marks in mathematics. That means my rank is 1. In case of mathematics, I got second highest marks in statistics. That means here my rank is 2. Second, that means 2. And in case of, suppose in case of business management, I got 4th highest. That means my rank is 4. So 1 plus 2 plus 4. That means 1 plus 2 plus 4. That means 7. 7 is the sum of ranks assigned to me. So this is R. And R bar means mean of R. That means sigma Ri divided by n, mean of R. So R bar, sigma Ri minus R bar whole square is the small s. And k is the number of variables. Here we have considered 3 variables: marks in mathematics, marks in statistics, marks in business management. That means number of sets of rankings or number of variables. This is k. And n is the number of individual ranks. Suppose we have considered 100 individuals or we have considered 20 individuals. So n equal to 20 or n equal to 100. But if tie arises, we have to use the second formula. Here one minus is missing. Here the formula is not correct. Actually the formula will be small s divided by 1 by 12 into k square into n cube minus n minus within bracket k into sigma capital T. Here one minus is missing. N cube minus n, bracket close, then minus, again bracket within bracket k into sigma T, capital T, where sigma capital T equal to sigma T cube minus T divided by 12. So small t equal to number of individuals involved in a tie. The same thing. So this W, that means Kendall's coefficients of concordance, varies between +1 and 0. That means the maximum value of Kendall's coefficients of concordance is +1 and the minimum value is 0. It varies between +1 and 0. That means it cannot be negative. Okay. Next to here also one thing is very important. If n is lower than or equal to 7 if n means number of individual under consideration. That means if we consider 50 students in case of, or if we consider 50 companies, or if we consider 50 objects, okay, then n, if n is greater, if n is lower than or equal to 7, then we have to compare the computed value of S with the table value of S, So in order to examine whether the computed value of Kendall's coefficients of concordance is statistically significant or not, S is the value of S, computed value of small s, is to be compared with the table value of S. If the computed value of small s is greater than the table value of S or equal to the table value of S, then we can say that Kendall's coefficients of concordance is statistically significant. But if the computed value of S is lower than the table value of S, then we can say that the Kendall's coefficients of concordance is not statistically significant, it is insignificant. When this rule we have to follow when n value does not exceed 7. Okay, that means n is either equal to 7 or lower than 7. But if n value, if n exceeds 7, then we have to use chi-square test in order to examine whether the computed value of Kendall's coefficients of concordance is statistically significant or not. We have to use chi-square. We have to use chi-square test, where chi-square equal to k into n minus 1 into W, where n is the number of individuals ranks, that means number of individual under consideration. K is the number of sets of rankings, that means number of variables. Here we have considered three sets of rankings: marks in mathematics, marks in statistics, marks in business management. If we consider 4 or 5, then K equal to 4 or 5, and W is the Kendall's coefficients of concordance. And here degree of freedom is n minus 1. So here the same formula, same principle we have to follow. If the computed value of chi-square is either greater than or equal to the table value of chi-square, the computed value of Kendall's coefficients of concordance is statistically significant. But if the computed value of chi-square is lower than the table value of chi-square, then we can say that the computed value of Kendall's coefficients of concordance is statistically insignificant. So the time is almost over. So very sorry. So we are not in a position to discuss the measures of relationship in case of attributes. Okay. So that's all. So have you any question? Hello.
Participants, please ask some questions if you have any doubts.
So we have already discussed the measures of relationship in case of variable.
Okay, sir. Excuse me, sir. Sir,
yes.
Here we have participants from many areas. So some maybe not from statistics background.
Okay.
So can you please
That's why I
explain?
have mentioned that this class is, this session is meant for the beginners, not for
Yes,
the
sir.
experts in statistics or research methodology.
Sir, the word which you have used, statistically significant, whether you can explain in simple terms so that everyone can understand this. Sir,
Oh,
please.
yes. Very good question. Actually, significant means, suppose uh, yield of the relationship between yield of crops and amount of fertilizer used. Suppose we got a correlation value and we have already examined by using t-test, okay, and we find that this t value is significant. That means, what does it indicate? It indicates that there is a relation, there is a noticeable relationship, there is a notable relationship between yield of crops and amount of fertilizer use. That means we can say that there is a noticeable influence. There is a noticeable influence of yield of amount of fertilizer on yield of crops. Okay, that means there is a notable relationship between these two. But if it is insignificant, then we can say that the relationship is not at all significant. The relationship is not at all noticeable. For example, in case of sales, in case of several companies, sales figure and profit. So we generally, it is argued that there is a or advertisement expenditure and sales figure. Suppose advertisement expenditure and sales figure, we know that advertisement is done for the purpose of enhancing the sales revenue. Okay, that means there should be a high degree of, theoretically we can say that there should be a high degree of relationship between advertisement expenditure and sales revenue. But if we get the a correlation value between advertisement expenditure and sales revenue is minus 0.57, so, and if it is significant, then we can say that there is a negative relationship between, there is a negative relationship between advertisement expenditure and sales revenue, and this relationship is statistically significant. That means noticeable. That means the advertisement expenditure, that means we can say that this result does not conform to the theoretical argument, because theoretically we can say that there should be a high degree of positive relationship, but here we find not only negative relationship, but this relationship is notable, this relationship is noticeable. That means the situation is totally adverse. That means appropriate measures should be taken by the management in order to take the decision regarding their advertisement expenditure. Okay, that means the advertisement expenditure that the companies have spent are not at all effective. Okay, so the relationship is adverse, this relationship is unfavorable. That's all. Thank you.
Thank you, sir. Very nicely explained. And I think if we could have got more time, we would have more understanding on measures of relationship.
Okay.
Thank you, sir, for sessioning this
Thank you.
program.
Thank you.
Sir. Okay, we have our next resource person,
Okay.
Dr. Hitesh Parmar from Sardar Patel University. And he is one of the most famous person in organizing lot number of workshop and FDPs on statistical softwares. He has been a resource person in more than 50 workshops explaining on social science softwares mainly. So we are grateful that he have accepted our invitations and he is in between us to take the next session. So over to you, Dr. Hitesh sir, and welcome to this session.
Thank you, sir. Thank you. Thank you very much, sir. Participants, we are going to use some of the files that I have shared in WhatsApp group. We are going to discuss a parametric test and in which I have shared some of the files with you in our WhatsApp group. So we can start this session as the time is only 1 hour. So we can start the session. Hi. बोलिए सर बोलिए हाँ क्लास So I hope the screen is visible, everyone.
Yes, sir. It is visible, sir.
Thank you, sir. Thank you.
Okay, sir.
So we'll discuss t-test today. Before reaching to the software, let us talk briefly about the fundamental aspects of the t-test, and then we can discuss the same types of t-test with the help of Jamovi. T-test, if we talk, then this test was invented by a statistician. His name was W.S. Gossett. So this test was invented by this person, W.S. Gossett. But he preferred to this name as a student because he was not allowed to publish his work. So he preferred the name student and then he published his work. So there is a brief story behind this publication. When he joined the organization, at that time he was working with this quality control department, and in quality control department his job was to accept or reject the lot at the end of the day. That was his job. So at the end of the day he was testing by certain parameters, and then if the product is found okay, then he was accepting, and if the product was not found okay, he was rejecting. He found that whenever he is rejecting the lot, at that time there is a huge loss to the organization because entire day's production he was rejecting. So he thought that why don't he should start sampling at some small interval of time. So he started collecting samples at some small interval of time, and then he has tested the samples. What he observed that whenever his samples was small, less than 30, at that time the shape of the distribution was not following normal distribution. It was something different from the normal distribution. And whenever the sample size is greater than 30, at that time he found that it is the normal distribution approximately. So he prepared a table for each of the sample size, and then he went to the management that he has invented something new. So management was happy because he has invented something new and it is really beneficial to the organization. But then Mr. Gossett told that I want to publish this work. But management didn't allow him to publish because the thought was like that if we will allow you to publish this work, then our competitor will also learn this technique. And if the competitor will also learn this technique, then they will also get the benefits. And the management didn't wanted to uh, allow or the learn the competitors will also learn that was not acceptable to the management. So they told that we will not allow you to publish this work. Then Mr. Gossett told that okay fine, I will not use my name, but let me use the student's name and then let me publish this work as a student's work. So in this way, the proposal is being finalized, and then the work is being published as a name of a student. So this is the brief history behind this t-test. This picture is of Mr. Goset in the year 1908, and then he was not allowed to publish, so he used the word student, and then the work is being published, and that is the reason it is also referred as students t-test. This test is also referred as students t-test. Now, what are the assumptions and requirement of t distribution? So the first one is the variable x is normally distributed. This is the assumption. Now, just a few minutes before we talk that whenever the sample size is less than 30, it was not following the normal distribution. Right, then how can we assume normality here in t-test? So there is a concept of z-test. Majority of you are aware regarding the z-test. So z-test is applicable when the population standard deviation and population mean are known to us. Means the population parameter are known to us. Whenever the population parameter are not known to us, at that time statistician says that if your sample size is greater than 30 but population parameter are not known to you, then you can go for a t-test. So t-test can be applied when a situation number one is the population parameter are not known to us and the sample size is greater than 30. Situation number two is sample size is less than 30. So in all cases where sample size is less than 30, yes, t-test is applicable, and at that time there is no need to check the normality of the data. When the sample size is greater than 30 and you are applying t-test, at that time you need to check the normality. So this assumption is applicable when the sample size is greater than 30 and you want to apply t-test. Then you need to check the normality. This is the case. I hope the point is clear, everyone. The first point, variable x is normally distributed, and I hope the everybody is aware regarding the concepts of normality. You people are familiar with these concepts of normality, hypothesis, right? I hope you are aware regarding the testing of hypothesis and fundamentals of hypothesis. Are you people familiar with the concepts of hypothesis? Okay. So should we proceed then? Then it is assumed that in t-test, the samples, whatever samples we are collecting, these samples are collected randomly. It is very similar to Z distribution, means normal distribution. It is very similar to normal distribution as sample size gets large, 30 plus. So it will follow approximately normal distribution when the sample size is 30 plus. The variance of the two groups is not different. If different, use alternative formula. So there are two formulas. Formula number 1 is applicable when the variance of the two groups is different. And formula number 2 is applicable when the variance of the two groups is not different. So it is a matter of whether to use formula number 1 or whether to use formula number 2. So we need to check whether the group variance is same or not. If same, then the software will use formula number A. And if different, then the software will use formula number B, like this. And there is n minus 1 degree of freedom. Now the concept of degree of freedom, why it is n minus 1? Because say for example, there is a cricket team and your job is to give fielding positions to each of the players. You are a captain and then your job is to give the fielding positions to each of your players. So one by one you are giving fielding positions. So for the first player you have all choices available and then you are giving the fielding positions. Then once you fix your player number 1, then you have, suppose you have 11 players. So once you fix the first player, so 11 minus 1, so then you will have 10 degree of freedom. Then again you are fixing the players one by one. But once you fix the 10 number of players, then you will not have any choice available, because whatever the last position available, that position you have to use. So that is why it is known as n minus 1. In this case, it will be the 11 players, so 11 minus 1, so you have 10 degree of freedom. 10 players you can fix anywhere, but for the last one you do not have any degree of freedom. So that is the reason the degree of freedom is always known as n minus 1. Now why it is applicable in t-test? Because whenever the concept of sampling will come, at that time the concept of degree of freedom will always come. So you are aware that in t-test you do not have the population parameters available. So population mean is not available, population standard deviation is not available. Then how to estimate those parameters? So to estimate these parameters, we are relying on samples. So we calculate sample mean, and then we think that samples are the representation of the population. So we fix our sample mean as a population mean. So for example, you have only 3 samples for our understanding. So 3 samples, we can have sample mean as x bar is equal to x1 plus x2 plus x3 and divided by 3. This could be our mean equation. Now suppose for 3 samples we found that mean is 50. So if mean is 50, then this answer 50 we can fix this as for population. So sample mean that we found 50 will become our population mean. So this answer is fixed, 50 is fixed. Then in how many ways we can put the values, how many degree of freedoms we will have for x1, x2 and x3 to get the answer of 50. So we will have 3 minus 1, so 2 degree of freedom to get the answer of 50. As the answer is fixed, so we have to substitute the last value. For example, if I substitute x1 is equal to 70, x2 is equal to 20, then I have to put x3 is equal to 50. Then and then I can get an answer of 50 as a mean. Otherwise, I will not able to get it. So that is the reason the concept of degree of freedom is applicable in t-test, and it is known as n minus 1 degree of freedom. To apply t-test or any parametric test, we require at least the scale of measurement is at least interval scale, means interval or ratio scale is okay. We cannot apply for nominal or ordinal data. So to apply t-test or any parametric test, we require at least interval data or interval or ratio data. If we compare Z distribution and T distribution, then it can be compared like this. The uppermost distribution is known as the normal distribution. So as the sample size becomes smaller, the distribution becomes flatter and flatter. You can see that the lower distribution is the T distribution at 5 degrees of freedom. Then the middle distribution is at 20 degrees of freedom. And the uppermost distribution is at 30 or 30 plus. So the distribution will follow approximately normal. So like this, you can just visualize and compare it with the normal distribution. Now, what exactly we are doing in t-test? So let us imagine that we choose 2 children at random from 2 classrooms. So there are 2 classrooms and we are selecting 2 children at random. And then what we are doing, we are comparing their height. So there are 2 children we are selecting randomly from 2 classrooms and we measure their height. Once we measure the height, then definitely what we found, we find that one student is taller than the other. Why? What could be the reason? What do you think? Why one student is taller than the other? Anyone? What do you think? So we have 2 classrooms and we randomly select 2 children. We measure their height and we found that one student is taller than the other. What could be the reason? Yes, anybody? What could be the reason?
Sir, reason maybe as sample size is only 2, that's why it may not represent proper.
Okay. Fine. So what should we do? We should
increase sample size.
Okay, if we increase the sample size, okay, and then we found that one group is taller than the other, then what could be the reason? So let us explore. Reason number 1 can be there is a significant difference between the 2 groups. So students in one group are taller than the students in another group. The age group are different. So one group is having a 7 years of age and second group is having 11 years of age. So definitely the 11 years of age will have a higher height than the 7 years of age. So it is bound to happen. So reason number 1 is natural difference. That there is a significant difference between the two groups. So difference is present, natural. Reason number 2 is by chance we picked up a shorter students from one group and taller one from the other group. By chance. Otherwise, the age groups are same. Both are having the 9 years of age, for example. But by chance, we picked up a shorter one from this group and a taller one from this group. So these could be the two reasons. Reason number 1 is a naturally significant difference. Reason number 2 is by chance. Now our job is to reduce the chance effect. So by chance element we would like to eliminate. So what should we do then to reduce the chance effect? So we should do more sampling. At this moment of time, our sample size is just 2, 1 from the each group. So to reduce the chance effect, we need to do the measure more students, means we need to increase the sample size. And then if we found that the significant difference between these two groups is having a difference, then the average or mean height of the two groups would be very different. If we found that the significant difference is present, then the average or mean height of the two groups would be very different. And if we found that there is no significant difference between these two groups, then the average or mean height of the two groups would be very similar. So in t-test, how many groups we are comparing?
2 group.
In t-test, we are comparing two. And on what basis we are comparing? What is our comparison criteria?
2 group must be continuous variable.
Yeah, continuous variable. But what is our criteria for comparison? On what basis?
Sir, height.
Please repeat.
Sir, height is the
Height is the
reason.
criteria. Okay.
Yes, sir.
But what we are comparing here? Of you?
We are
We are comparing mean.
We are comparing mean or
Mean.
average. Right? We are comparing mean or average. So always remember that we are comparing on the basis of mean or average. And always we are comparing two groups of mean in t-test. So whenever in your research, if your agenda is to compare two groups, then your answer is t-test. Whenever in your research, if you wish to compare two groups of mean, then your answer will be t-test. Okay? But mean cannot alone represent the data. You all are aware. So we need to add something to this mean. What should we add along with mean? What do you think? To support mean, what should we add for comparison?
Standard deviation.
Yes, perfect answer. Standard deviation. So along with mean, we need to add standard deviation because living things normally show a lot of variation. So along with mean, we need to add standard deviation. And it is very unlikely that the mean height of our two samples will be exactly the same. So that is the reason we need to add mean and standard deviation. So standard deviation we can analyze through histogram visually. Just look at these two pictures. The upper one is having a range from 140 to 169, a lower one from 160 to 189. What is common in these two between 160 to 169? A very small portion is common. So maybe the ranges of the two samples have a very small overlap. So difference between the means of the two samples is probably significant. You can say that the difference is significant. You can say that because a very small overlap in the category 160 to 169 you can observe. Now the second one. Here you can observe that the samples have a very wide overlap, 140 to 189, 140 to 189. So you can say that the difference between the two samples may not be significant. And the difference in mean is observed because of a random sampling error. This could be the reason. Otherwise, the difference is not significant. So to decide if there is a significant difference between two samples, we must compare the mean height of each sample and the spread height of each sample. So mean and standard deviation will be our criteria to compare two groups of this mean. Now just open the software Jamovi and open the file independent sample t-test that I have shared with you. Just open the file independent sample t-test. Just let me know whenever you are ready with the file. Just let me know whenever you are ready with the file. There is a question that why it is called independent sample, because the samples are independent from each other. Then afterwards we'll also go through the dependent sample t-test, so in which the samples are dependent on each other. Right? Both samples are dependent on each other. The groups that you are comparing here, we understood that t-test is a comparison of two groups. So the groups that you are comparing are independent from each other. Are you ready with the file? Independent sample t-test.
The file has been sent also in their mail, sir.
So, as I am getting messages that majority of the participants, I hope they are ready with the file. Now, independent sample t-test, any naturally created two groups you can compare. Any two groups. Right here, the data you are comparing the monthly mobile bill of male and female respondents. Similarly, you can compare any interval or ratio scale variable with respect to two groups. These two groups can be respondents obtained from two different cities, or it can be two types of organizations, maybe large scale and medium scale, or it can be two age group, it can be two occupational group, or whatever two groups that you wish to compare, that you can compare. Can you give me some examples where you would like to apply independent sample t-test? We require two variables. One variable is a dichotomous variable. It can be maybe gender or two categories of occupation, two cities, two states, like this. And second variable is either interval or ratio scale variable. So from your domain of study, can you give me some examples of independent sample t-test where you would like to apply? Anyone? So that I will understand that, okay, fine, you are able to understand the concept, and then we can move ahead.
Yes, sir. Maybe is there any significant difference between rural and urban people of monthly bill electricity?
Rural and urban
Population monthly electricity bill.
monthly electricity bill. Okay, yes. So monthly electricity bill is a ratio variable. Rural and urban will qualify as a dichotomous variable. The answer is perfect. Then demand of product A and product B. Yes, it is also correct. Demand of product A and product B, you can compare the average demand with respect to two products. Any other example? Any other example?
Maybe a smoking rate between two group, male and female.
Please repeat, sir.
Smoking rate between two groups, either male or female, or between rural and urban people. So we can.
Sir, how will you measure the rate of smoking?
The number of count, sir. Number of count. If we
Number. Okay,
yeah.
fine. Perfect example. Yes. So you can compare. Yes. Any other participant? You can unmute yourself. You can type whatever way you are comfortable. Anyone? Okay, fine. Let us continue then. So to apply independent sample t-test, you need to click here on t-test, and then you will need to find this independent sample t-test, the first option. Once you click here, independent sample t-test, then you will get this dialog box. You need to transfer monthly mobile bill as a dependent variable, gender as a grouping variable. Then your first task is to check the assumptions here. So we need to check the assumption of normality and assumption of homogeneity test. Assumption of normality and assumption of homogeneity test. Now let us just look at the assumption of normality. Here, please write down the test of normality if you are not comfortable, or if you are not applied this test before in any other of the software also. Null hypothesis for the test of normality is the data are normal. This is the null hypothesis. What is null hypothesis? Data are normal. Null hypothesis is data are normal. Now what p-value we get here? The p-value we observe is 0.087. So which is greater than 0.05. And we can confirm that data are normally distributed. As the p-value is greater than 0.05, so we can confirm that the data are normally distributed. I hope you people understand it. Null hypothesis is data are normally distributed. P-value is greater than 0.05. So you fail to reject the null hypothesis, and you can confirm that data are normally distributed. Is it okay, everyone? Understood? Assumption of normality, how to check? Just look at the p-value. The p-value should be greater than 0.05. If it is greater than 0.05, you can confirm that the data are normally distributed. Should we move ahead, everyone?
Yes.
Okay. The second assumption is homogeneity of the variance, this one. Now here, please write down, there is no significant difference. There is no significant difference between the variability of the two groups. There is no significant difference between the variability of the two groups. So with respect to variability, your null hypothesis is that the significant difference is not present. Both groups are having equal variability. This is what our null hypothesis is. Now what p-value we get? P-value we get is 0.884. The p-value we get is 0.884. So we can just fail to reject the null hypothesis, and we can confirm that with respect to variability, both groups are same. So we can finally conclude that there is no significant difference in the variability of the two groups. Understood, everyone? So variances of the both groups are same, finally. Normality is also okay. Variances of the both groups are also same. These two assumptions we check before applying the t-test. Understood, everyone? Any problem? Okay. Now let us tick mark descriptives. Let us tick mark a mean difference and confidence interval of the difference. Now, the second thing that you need to observe is the group statistics. So group statistics, the female respondents mean is 431 and male respondents mean is 429. A slightly higher female respondents mean we have observed. So by looking at the sample statistics, we can say that, okay, fine, the female group's mean is little bit higher than the male group's mean, but whether the mean difference is significant or not, that we need to check. So to check this mean difference, the p-value we will require p-value. And this is our p-value, 0.707, this one. This is our p-value, 0.707. So we can say that the difference between these two groups is not significant. It is just by chance because the p-value is more than 0.05. So we fail to reject our null hypothesis. And we can confirm or conclude that there is no significant difference in the average monthly mobile bill between male and female respondents. We can confirm that the difference between these two groups is not statistically significant. And whatever the mean difference we observed, 1.47, is just because by chance. Otherwise, statistically, the difference is not present. Understood, everyone?
Yes, sir.
Any question? Any question?
Sir, a question has in the place of normality test has been written in bracket. Shapiro wiki. What does it mean?
Though your voice is breaking, I understood that you ask from the normality table, and then your question is the Shapiro-Wilk W.
Yes.
This is what you want to ask.
Yes, sir.
Yeah. See, this Demovi gives the Shapiro-Wilk test. By default, test is Shapiro-Wilk test. Right? So the normality test can be done by so many types of tests. So out of all these alternatives available, Jamovi gives us output for Shapiro-Wilk test. Now, in which this W is called the calculated value of Shapiro-Wilk test. W is known as calculated value. So, for example, if I go back for our t-test formula, so this is our t-test formula. So x1 bar minus x2 bar divided by this standard error. So this is the formula, right? So answer that we will get, this is known as the t calculated. So this is a formula for t-test and answer that we get is known as t calculated. Similarly for this also, it is known as w calculated. This Shapiro-Wilk test, this is known as W calculated. And then the answer that get we is 0.95, right? Like this, here also in t-test what we get, this one statistics, 0.37. So it is known as t calculated. Similarly, 0.95 is known as W calculated. Now against this calculated value, the software generates a p-value. And based on this p-value, we need to take our answer that whether the difference is significant or not, or whether the distribution is normal or not, based on this p value we are generating. So w, this calculated value is depending upon this w calculated value, the software will be generating this p value, and final conclusions will be taken based on the p value. So any calculated value, for example, here in this statistics, if this calculated value is greater than 1.96, then you will get a p value which is less than 0.05. So the lower the value, it is quite possible that the p value will be more than 0.05, right? And higher the value, the lower the p value. So this is the inverse relationship between this calculated value and a p value. So in this way we may interpret the t-test. I hope you are able to understand it. Now the software also generates this 95% confidence interval for lower and upper limits. Now, how to interpret this 95% confidence interval? So for this lower limit, it is said that it is minus 6.39, and for upper it is plus 9.33. Now it can be interpreted as that, for example, this time we get a mean difference of plus 1.47. Now suppose next time, second time, if we conduct same experiment from the same population, if we again collect a same number of respondents, maybe 41, then definitely we will not get the same mean difference. It will be something different, right? Exactly 1.47 we will not get. Third time also, if we conduct such experiment, then definitely we'll get some different mean difference. Then our question is that, can we get a range of the mean of the difference? So this software provides us this range, and this range is minus 6.39 to plus 9.33, and its probability is 95%. So what are the chance that you will range of the mean of the difference in between these two? The chance is 95%. There is a 95% probability that the difference you will get will be in the range from minus 6.39 to plus 9.33. I hope you are able to understand it. Everyone understood the difference, range of the difference, 95% confidence interval? Understood, everyone? Now, one range is negative and one range is positive. So how to interpret this lower and upper limit? So this time we get a positive mean difference. So when we get a positive mean difference, how can we interpret a positive mean difference? Which mean is higher? Male mean is higher or female mean is higher?
Female.
Female mean is higher, right? So that is the reason you get a positive mean difference. Now a negative mean difference means what?
Male mean will be higher. Okay.
Negative mean difference means what? You get a negative answer. It means what?
Male mean will be higher. Sorry.
Male mean will be higher, right? So the limit is plus also, so it is indicating that there will be some situations in future in which male mean will be higher than the female mean. This time by default you get a female monthly mobile bill higher than the male one. But in future, you will have a situation when male mean will be higher than the female. Is it okay? Clear, everyone?
Sir, why negative for male and positive for female?
Why?
Negative value is for male and positive value is for female.
Yeah. See, this time the answer you get is the positive 1.47. So 431 point something minus 429 point something. So that is the reason you get a plus value, because female mean was higher than the male mean. So this equation is x1 bar minus x2 bar. So that is the reason if the first mean is higher than the second mean, then only you will get a positive mean difference. That is the reason. Understood?
Yes, sir.
Okay. So this is all about independent sample t-test. Now, second type of t-test is known as the dependent sample t-test. And third type of t-test is known as the one sample t-test. So let us again further explore. So just open the file one sample t-test. Let us do one sample t-test. Open the file one sample t-test. Just let me know whenever you are ready with the file. So when to apply, first of all, this one sample t-test, when to apply. See, whenever you wish to compare your sample mean with any standard mean, then you can apply one sample t-test. A sample mean will be compared with the standard mean. So in this case, there is a manufacturing organization and the standard weight of the product is 500 gram. So we collected some samples randomly and then we measure their weight. And our objective is whether the sample mean is significantly different from 500 gram or not. So again, in one sample t-test, again what we are doing, we are comparing our sample mean with some standard or specific value. So null hypothesis will be no significant difference between a sample mean and a standard value. An alternative hypothesis will be there is a significant difference between a sample mean and a standard value. So this is what we are just checking when we apply one sample t-test. So I hope you people are ready with the file, everyone. One sample t-test.
Yes, sir.
Yes, okay. So to apply one sample t-test, just click on t-test and one sample t-test. Transfer weight underscore gram as a dependent variable. Click on the normality test, descriptive, mean difference. The first task is normality. The p-value is 0.065. What we can interpret? 0.065 p-value, normality. Is it normally distributed?
Normal distributed because value is more than 0.05.
Yes, sir. Yes. So as the value is greater than 0.05, so we can say that the variable is normally distributed. Then our null hypothesis. P-value is less than 0.001 here. So what we can interpret? Null hypothesis is as the p-value is less than 0.05. So what we can say, null hypothesis is?
There is significant difference between.
Please repeat.
There will be significant difference.
Yes,
That
yes,
is,
yes. As the p-value is less than 0.05, we reject the null hypothesis, and it can be concluded that the difference is significant. There is a significant difference between a sample mean and a standard mean. Now, one more thing that we need to change here that we didn't change is what is our standard value here. In this case, what is our standard value?
500 gram.
500 gram. So our standard value we have to put as 500. We have to put a standard value as 500. So then only it will be tested against our sample mean. So the difference is significant. So we can conclude that the sample mean is significantly different from 500 gram. As the p-value is less than 0.05, so we can conclude that sample mean is significantly different from 500. Any question from this test? Anyone? We discussed two types of t-tests, independent sample and one sample. So if you have any question, any doubt, you please ask. Any question, any doubt? We'll continue these types of t-test and other parametric, non-parametric tests in our next class. Up till now, whatever we have discussed, if you have any question, you can please ask. So should we conclude our session then? Anyone, if you do not have any question?
Yes, sir.
Okay, fine then. Then we'll meet next time whenever my session will be there, and we'll continue from this test. Okay, fine. Thank you. Thank you very much all.
Thank you, sir.
Thank you. Thank you.
Thank you, sir, for being with us. It was really an interactive session. As how you have explained so easily how to handle the Gemovis software. Thank you, sir. We hope to see you in the next session, sir. Thank you.
Thank you. Thank you very much. Thank you.
Respected participants. Yes, sir. Yes, thank you, sir. As participants, so today we end the session here. Tomorrow we shall be back at 11 a.m. So we'll start our session with one of the renowned professors of Rajasthan, so Professor Karunesh Saxena. So we do hope that everyone will join for his session. Thank you. Thank you, everyone. Thank you, sir.